Hey, welcome back to the channel. Good to see you again. Hope you're all well. Thanks for joining. Today on the bench I got a Samsung TV. I believe it's a 40-inch. I'm not sure. But this was given to me. Let's tell you the story behind this one. Person we know through a local club. They are moving from Canada back to Florida, and they are unloading a lot of their unwanted stuff. So they had me come over and take a look at some of the things that they were getting rid of, and I went over. And today the lady said, take this TV. It's not working. I tried fixing it. I don't know what's wrong with it. I think it was the power board, but then I thought it was the control board. And then she says, well, I think it's the LEDs. I didn't get it fixed, but I gave it a try. And it's all there, just take it. So I took it home, and we're going to have an attempt at this. I don't know what to expect when I open it up. I asked her, is the stand there? And she says, yeah, it's in the bag. But I looked in the bag, and there's no stand. There's just a remote and a power cord. So let's have a look at this and see what's going on with it. So this is basically how I got it. Had a bag taped to the back, and it's got a remote with batteries, and it has a power cord. It's got a few loose screws, more than a few. There's quite a few here. And this odd looking plastic piece, I don't know what that is. It might be something for, yeah, I don't know. I don't know what that is. But that's what came with it. And the TV itself, it was taped together. It's got tape on both sides. So if I remove the tape on this side, I think this will lift up. Not sure. I don't think they have any screws left in here. I think she took all the screws out. Anyways, I'll open it up and I'll have a look. Alright, so here's a look at the tag. I can get out of the light here, maybe you can see it better. It is a model UN40EH5300 FXZC. So from the model number, I'm guessing it's a 40-inch. And data manufacturer May of 2014, so it's not a really recent television. It's got some seniority to it. It's an LED TV, I believe. Typical power, 33 watts, slow power. Usually I don't mess around with TVs, just for the simple fact that the ones I pick up usually have busted screens, and they're not really worth my time, so I just scrap them for power supply parts or whatever I need out of them. And but I'll fix this one up. I don't have a need for it, and I'll fix it up. Maybe somebody I know needs a television without a stand, so we'll see what we can do here. Okay, I'm in, and it looks all complete. She even went to the trouble of labeling the boards for me, which is nice. Main board, power supply board, T-con, and yeah, it looks pretty nice. But everything's here. Everything's harnesses all here. Everything's here, so that's a good sign. Don't know what it's doing or not doing yet. We could plug it in and give it a try. This is the little joystick. It's on the bottom. Here's a Wi-Fi dongle. Everything's plugged in, so we'll give it a try. We'll see what it's not doing, and we'll see what it might need. I'm guessing it might need some work on the power supply. It looks pretty cooked. It's pretty cooked around this area here, so it's hard to say what it might need. Alright, so I got it set up. We're going to give it power, so I'm plugging it in. And I'm going to use the remote to turn it on. The light is on. And the light is blinking red. It's not coming up. Let's try that again. I know you can't see anything because the light is behind the screen right now. Okay, kind of. Five blinks. I don't know what that means. Let's try this again. Let's let it discharge. One more time. 6 blinks, not 5. Okay, so something to start with. It's completely dead. It's blinked 6 times. The power light. So let's go see what this says on the interwebs. I got the main board here removed. Main power supply board here removed. This is not the main board. This is the power supply board. Sorry. So where do we start? Where do we start hunting for the fault on this television? Well, first you check out the power supply. That's typically the main thing you do first. And in any of these switch mode power supplies, televisions, stereos, whatever, doesn't matter what, these 2 main filter caps can hold a lethal charge, so you want to check them. And we're going to just check them, see what they hold. Can't really see that. You can probably see it better than me. Okay, 0.6 of a volt, that's nothing. And they're both, these caps are wired in parallel, if you look at the board here. So actually what they're doing is they're getting a 200 microfarad at 420 volts. So it's 1 capacitor. Now everything, this big thick white line here is important to any service tech, because everything on this side will be isolated from this with this transformer, all the mains voltage. Everything on this side of the board is at mains voltage. So we got power input, fuse, signal conditioning, and filter, EMI filtering. We got capacitors, common mode chokes, you name it, bridge rectifier, the main filter caps for storing the rectified DC, and then we have our main MOSFET that's going to chop the DC into a signal that's going to be fed to the transformer, which in turn makes secondary voltages. So everything on this side is going to be at mains voltage. And now that we have, we know that we plugged in the TV set and it started blinking 6 times, we know we're getting power, because that LED would not blink if this side was dead. If this side was completely dead, if this fuse is open, let's say for example, we would get no blinking LED. So the fact that this LED is blinking can tell us that this side is working. We pretty much know the fault's not here. Now this side's a different story. This side has different supplies. We have, if you look here, can't read it on this camera, but I can read it to you. 13 volts, PWM _DM, B 13 volts, that's a B plus. Blue, V amp, ground, and A 5 volts. And 5 volt power on and off return. And here we have some other voltages. D plus, S1 minus, S2 plus, no connection, S2 minus, S3 plus, D minus, D minus. So I think this might be the LED output. And this might be the LED driver circuit here. And the rest of this will be for powering the main board and the T-con. So where do we start? Well, give it an inspection. You don't see any burnt parts, but everything looks good so far. Typically, the way it works is you have your secondary winding. Let's start here. You have your power coming in, fuse. We did all this, bridge rectifier, main filter, chopper transistor, feeds it to the primary coil of the transformer. Now the secondary coil, there might be, let's have a look here, let's see. This is the primary coil here. In the secondary, we got 1, 2, 3, 4, 5, 6 pins. So we might have 3 different windings here, considering there's 6 pins. And they all seem to be attached and working, something. This one, for example, goes straight to a diode. So that's one DC supply. This one here goes straight to a diode. This is like a negative DC supply. This one here goes to the other diode. This is a positive DC supply, so that is a plus minus. Yeah, they're both the same. Where does that go? Just ends there. That's odd. Okay, and then this one here, this one looks like a ground because it is all encompassing. So this one goes all the way around. This is probably a ground. This one here goes to 2 diodes. And this is a positive supply here. Last one goes to 1 diode. And this is another positive supply. So it looks like we have 1, 2, 3, 4 supplies. 1, 2, 3. I'm not sure about these ones though. This is odd. Where does this go? It doesn't even connect to anything. 1, 1, 2. Let's just call that 2, 3, and then there's 4. 4. So there's 4 supplies, it looks like here. And for the TV to work, all those supplies got to be up and running. So maybe we have a supply that's out. So how do we tell? Well, let's get our diode checker. And we'll check all these diodes. If any of them are shorted, that's our culprit. So let's check this one. That's good. Good. Ah, look at that. Look at that. That one's awfully low. So what's going on here? This is dead short. This comes off this winding. There's a small capacitor here, this little blue one. This one here is a, I don't know what that is, 221. So what is that? That's 22 picofarads? Something like that. It's a low value, very low value. Comes up here. This one here, yeah. Yeah, capacitor, and then it goes to these 2 diodes. And then goes to this supply. This supply goes to this transistor. I don't know if that's a regulator or what. Okay, let's take these 2 diodes out. Let's see which one. One of them's got to be shorted. They're both wired in parallel. So let's do this. We got our iron on. Where is it? Right here. Actually, I can just, with the one lifted, I can test them now. Okay, back on diode check. That one's shorted. That one's still good. So let's pull out the other diode. It's unusual for a diode to just short like this. They got it overheated for some reason, who knows. Pull this one out. Okay. It's an SR315. It's probably a Schottky rectifier. That's probably what it stands for, SR. So let's try this one more time. Oh, now it's open. What is going on here? Let's check the board. No more short on the board. Did I pull the wrong diode out? No. This is weird. I've never seen the diode that... Okay, you know, I'm going to put this back in. Alrighty, so I got fooled here. I'll show you what happened. These diodes seem to be okay. There's no leakage that way, and they show forward drop of 4 volts. Same with the other one. Now if I go across here and here, I get 0. See, that's what threw me. And what that is, there's a big capacitor here somewhere that's charging up, and that threw me for a loop. I thought maybe it was this transistor, so I started checking this transistor and it looked okay. That one looks okay. Nothing shorted there. I don't know if it could be a MOSFET for all I know. I haven't looked at it. But what threw me was that big 0 when I went across here, and it's just charging up. If I go opposite voltage, get 0. If you wait a while, then it charges up. So that can catch you. That's no big deal. Let's check some of these capacitors, because these are probably starting to get tired. So let's go get our ESR checker here. Check some of these caps out. Okay. What do we got here? Let's check these two first. $210 milliohms. Remember, these two are in parallel with each other, so that's good. Let's check this one. $330 milliohms, that one's okay. This one here. $40 milliohms. This one here. 0. Shouldn't read 0. Should read something. Maybe that cap is shorted. Here's another one. 10 milliohms. This one here. Oh, now we get 0.2. Okay. And these little ones. 100 milliohms for that one. And 110 milliohms for that one. Another cap here. 1 ohm. That's not good. Well, hang on. It's a 22 microfarad at 350 volts. So that might be okay. 22. Yeah, it might be alright. And then aside from that, there's these little one here. But that's on the primary side. Let's check it. $230 milliohms. Where is the fault? Reveal yourself. So what I'm going to do is I'm going to continue checking the rest of these diodes. I think I checked this one, didn't I? That one's okay. I checked these two. There's one here. This is for the LED supply, I believe. Okay. And then that's it. There's a big transistor here. That would be a emitter collector base. Is that right? Now there's about 100 little parts here, 100 transistors, diodes. Any one of these could have failed. Let's check this one here. Looks all right. I'm not finding any faults here. So let's put these diodes back in. And we'll solder that back in. Make sure they push through the board. Another thing we can check is some of these resistors here are low value, and they will be used as a fuse resistor. So let's try some of these out here. This one here looks like it's low ohms. It's 1 ohm, that's right. This one here is 2 ohms. Yeah, who knows. Got 4 resistors in parallel here, and they are 150K each. So this should be somewhere around, what's half of 75? Yeah, that's about right. This resistor here. Can't see. 39 ohms. Does that sound right? Brown, black, brown. I'm not sure. 100 ohms. Another one. Same resistance. So we pretty much checked out the power supply board. Everything seems to be working. What does this say? Connector 803. Here's 803. Connector 802. Connector 802. Connector 802 LED 135 volts at 425 milliamps. That's what should be coming off of here. Let's see, how is that wired? Oh, they're all wired in series. So you're supplied with power on this one and this one on the outside, and these other ones are wired in series, it looks like. So without the plug in place, you won't get current flowing through. So between 1 and 9 we should have 135 volts. Okay. So A 5 volts, this should be 5.3 volts at 18 milliamps. B 5 volts, where's B 5 volts? There is no B 5 volts here. B 5 volts is 5.3 at 1.2 amps. B 5 volts. B 13 volts is 12.8 volts at 1.9 amps. B 13 volts here. V amp is 12.8 volts at 0.4 amps. Where's V amp? Those two. Okay, let's power this thing up and see if we confirm our voltages, if they're present or not. So far everything looks good on this power supply. Alright, so what I've done is I put the power supply board back in, and I'm going to do some more testing. It seems everything's fine with the power supply. So I put it back in. I was going to confirm some voltages. I'm going to start with the LED. You can't see it's up above the top of the screen here, but it's connected to the LED output, and I got a meter down here, and it's on DC volts right now. I'm going to plug this in, and we're going to see what we get for a response. So here we go. We're going live. Actually, there is an LED here. I want to put this so that you can see that as well. And maybe, hopefully, we can get a good look at everything that's going on here. Okay, can you see that LED? Hope so. Plugging in. So this LED blinks for a while. We got power on the T-con board. There's 3 LEDs lit here. So I'm just going to let it do its blinking thing for a while, and then I'm going to turn it on with the remote. And it should be on now. I'm getting nothing out of the LED supply. Wonder if that's a problem. TV should be on. The light's on steady. The lights on the T-con board went out. Got nothing on the screen, no lights, no nothing. So this is a mystery. Hang on, we got something on this side of the resistor. Not really. Oh, we got some voltage here. So we got something wrong with the power supply circuit for the LED driver. Doesn't seem to be putting out any current or anything at all. Let me see if I can get a measurement on what's going out to the LEDs. This is the hard part. There's no place to clip on here. Looks like 190 volts, I'm not sure. If that's the case, we might have an open string on the LED. And it looks like we have 3 strings, independent strings coming back. There's 3 cables. Let's check the LEDs out. So the most difficult part was separating the LCD panel from the LED panel. And you got to be very careful because there's fragile connections, and there's actually 2 series of clips around the outside that you have to release. The first series of clips takes out the outer frame or bezel, and that would be beneficial if you could remove that first, and then you remove the second series of clips, which removes the LCD frame from the chassis, and then what you're left with is the steel chassis with the LED panel. So here we got couple layers. You don't want to mix these up. You got a translucent light diffuser here, and then there's a thicker translucent panel. When you open it up, there's your LEDs. And I think this reflector comes out. For the most part it does. Oh look, we have already it's starting to reveal its fault. We got a burn mark here and a burn here. So we got a couple of clips to remove, and then we can remove this reflective panel, and then we can start working on the LEDs. So here we are again at the power supply board. Here's the LED connector, and there is actually 6 pins that are active on this. If you look on the back side, there's 1 pin here, 2, 3, then the center is not connected to anything, and then another 3 pins, and that corresponds with the 6 wires going out to the panel, because there's 3 strings of LEDs here. I drew it out for you. We have power supply here. These are the connections. We have 6 strings, or sorry, 3 strings with 6 wires of LEDs, and there's 13 LEDs in this string, 12 in this string, 13 in this string, for a total of 38 LEDs in series. And they are wired in series. I checked. And let's say each LED has nominal voltage of 3.2 volts. That's 121 volts across these to light them up. It probably varies depending on brightness adjustments and whatever. So what happened here is, I removed this string of LEDs that had the fault. Now I was looking at this under the tape. I thought maybe there was some surface mount resistors or something on here, but it's nothing. It's just a copper trace, and it arced to the metal chassis. And I believe what happened was this might have got damp or moisture got in here, and it arced to the ground, which is metal chassis, and that's open circuit. This is 195, 200 volts, and the current flew through that tape, or floated, whatever, through the tape, and it started arcing, and this is what the result is. So what are we going to do here? Well, it's a pretty simple fix. We can just jumper that, right? And we have to check if this LED is gone. So let's do that. That's pretty simple. We'll do that right now. So I have a power supply. I got it set for 13.6 volts, and then I have a 1,000 ohm resistor in series. So this will be for testing. So we can go here on these little pads and test if these LEDs are alive or not. We got nothing on that one. Let's try this one. Maybe the whole string is dead. I don't know. If you can find one good LED in this, it would be awesome. They could be all burnt for all I know. Let's try another one. Wow. Let's go to the other end and try this. I'm pretty sure these little dots here are for testing. I'm just trying to look underneath the lens. It's not possible that they're all dead. Is it? Is it possible they're all dead? Oh, there's one. Okay, we got one. See if we got 2. Yes, we got 2. Okay, let's try this. 3. 4. Guess I was trying the wrong dot there. You have to go in series. Okay. Just keep checking all these out. This one doesn't work. This one's dead. Hang on here. Okay. Dead, dead, dead. Let's mark it. Where's my marker? All right. dead. Okay, let's see, this last one I don't think it's going to be working. No, it's nothing there. This one might have been the one that started the whole chain reaction. We got a couple of dead LEDs here, and if they're shorted, that creates a problem for the rest of them, because when they short, they actually they reduce. Every time a diode shorts, the current goes up because this 3.2 volts in the string disappears. So instead of 121 volts, it'll only take 118 volts to light the string up. But we're still powering it with 121, so there's actually the current goes up, and then it stresses the remaining LEDs into overheating and dying. I just want to check these, make sure. Nothing on this one, eh? Okay, I'm going to go back and check the other two strings on the back of the panel, and I'll see what else is wrong. So we got 3 LEDs dead on this one. This one here is dead as well. So the verdict is in. I have a total of 12 dead LEDs. Majority of them are shorted, and I have one that's open. 1 or 2 I believe is open. So it's a good thing I have extra LEDs. I just salvaged these from another Samsung TV, and I can use these LEDs to get this one going again. So I'll warm up the soldering iron and I'll get busy on that. I'm not going to show it all. It's going to be just boring, tedious soldering, little micro LEDs, and get this thing back going again. Here's a little look at the carnage here that's on the first LED. We'll call this ground zero. This is where the fault started, I think, or the main fault anyways. I popped off this lens, and you can see the LED is pretty normal looking on this side, but this side is completely charcoal, and charcoal all the way up. The trace, this trace came off. You can just remove that, I think. Yeah, because this actually goes here, and then it opens up and it goes about 1/4 inch wide here, so that's probably the reason why that stopped there. And here's what's left of the trace. A little bit of ash and half an LED stuck to it, just like that. So I can't remove this LED and solder a new one in like I was doing here. Here I already did a solder job on this one. I replaced this LED, and I replaced this LED, and these are working, but I can't do anything with this. All I can do is I don't know what I'm going to do here. I think what I'm going to do is I'm just going to take one of these replacement LEDs and just mount it to the board. Get rid of that. Scrape this off and make it flat, and just glue this on, and then I can just put some jumper wires on, and it'll be in the same position, same LEDs, just it's going to be on a little piece of fiberglass board. This is actually aluminum strip, and it's quite difficult to solder to because it wicks all the heat away, and you got to really put a lot of heat to this. Like this one here, I think I cooked it a little bit too much. The LED's kind of gray, but yeah, you got to do what you got to do. You got to get that LED off and get a new one on there. So I'll do the same here. I'll just clean this up, and then I'll glue this on with some silicone, and then we'll put some jumper wires, and that'll be the end of that one. And then I'll move on to the other 2 strips. The other 2 strips I got, let's see here, 1, 2, 3, 4, 5, 6, 7, 8 LEDs to change out, 8 or 10. And I'll get on that, and then we'll get this back together. Now that I had a good look at this, I don't even know if this is repairable, because all the carbon tracking that's going on here. You got to remember, we're dealing with over 150 volts or maybe more. And there's one conductor here that runs from this positive terminal. It runs all the way around the outside here, and it's cut from here to here because of carbon tracking and burnt. It's all burnt away, and that continues on. It goes on to the, I don't even know where it goes. It goes to the other side of the strip. And then there's the pads for the LED itself. this one here, the negative pad is intact, but then there's also the insulation underneath it is all burnt and charcoal. So I got to dig all that out and clean that. Also, you can see here it's arcing here. It was arcing here all along this side. It was burning away, and between the aluminum substrate and the copper trace, there's all this carbon tracking. And then right here where the connection finishes off, see if I peel it back, there's carbon under there. I got to peel that all back and clean out all that carbon, just so that this will work again, because if we apply power to this, all this carbon is going to just start conducting and ignite. I bet you if I measure between this pad and the aluminum, I'll get a reading. Let me try this. My ohm meter here. And what are we going to have? So if I measure from this pad to the aluminum, I'm getting 51 ohms, which is not very good. I got to correct that so it's infinite. So what are we going to do? We have to do something. I'll keep picking away at this, see what I can do, and I don't know. It's going to be hard to reconstruct this. The problem is the aluminum substrate is conductive, right? And that's acting like a ground plane, and everything else is, see, like this is all carbon here. If I peel this back more, let me see if I can peel that back. I can peel it back. See how the carbon, you can see the carbon track on the underside of the, I don't know if you can see that. Maybe you can't. Let me try. Yeah, you can't really see it, but the carbon is eaten away underneath at the insulation all the way up to here. So I can peel that back, that's safe. I'm going to go this way now. I'll clean this up and I'll see what I can do. Okay, I'll show one of these LED replacements from start to finish, just so you have an idea of what I do. It's not that hard, it doesn't take me long. It's just a few minutes. Pop off the lens and throw it away. I got new ones, or used ones. So there's our LED. If I look at these ones, the yellow resin that they put in here to seal off the die and the bond wires is all cracked. I think that's the reason why these LEDs fails, because they run at high heat and then they crack, and then that's the end of it. So anyways, we're gonna remove, oh, before I start, I have to check. Every LED has an orientation, and this one has a little nick on the top right hand corner, so I put a little thing with the marker just so I don't get mixed up or backwards. And we'll just remove this LED using hot air. I'll just heat it from below. And a pair of tweezers here. As soon as the solder melts, it'll drop off the board. Like I said, it takes a while because the aluminum sucks the heat away. And when it gets to temperature, it'll come free. I got my heat gun here cranked up to max 450. Come on, it doesn't take this long. What's going on here? Ouch. As soon as I turn the camera on, it doesn't want to work. Just going to cook it from above then. There we go. I'll get rid of this. It's dead. Now, I like to retin the pads. So I'll just go and retin these. Probably got too much on there. Let that cool for a bit, and then I'll clean it with alcohol. Now, we need to get our replacement LED. There's one. Let's test this. So this was working. We saw it flash, we know it's working. So let's get rid of this one. And let's take this one off. Heat it from the back side. Okay, ready to put it on. We gotta make sure it's orientated right. I gotta check the corners up at the top right, so that's the right way. I'm going to heat this from below. As soon as I see the solder start to melt and flow, I press down on it and then remove the heat and let it cool. So just gotta keep an eye on it here. I think it's straight there. Press down. That should be it. Now there's little blobs here, I don't know. You can remove these. You not harm anything. So let's test this again. I can't remember which way is positive, I think. There we go. We got a working LED. So I got one more to do on this strip. And then I go on to the last strip. I got 1, 2, 3, 4, 5 on the last strip. I got so 6 more to do. Now that all the LEDs are soldered in, I'm going to do a final test and apply it to my power supply. It's current limited to about 30 milliamps, so I'm just going to crank up the voltage here. Start going up and make sure all the LEDs are lit. Right around 30 volts it starts coming up. 35, there we go. I got a dirty pot on my supply. So it's 34 volts, current limited to 60 milliamps. All the LEDs are lit. So I'll test the other 2 strips and then we'll reassemble. So now that I got the LEDs all replaced, the defective ones, and I've tested the 3 strips, they all work. All the LEDs are lit. We're going to secure these, they're light spreaders. They're little plastic lenses that diffuse the LED light. So they have to be pretty much centered directly over the die of the LED. So I'm just going to put a blob on each side, clear silicone, and I'm just going to center this over top and just let that set up. Alright, here we go. First power up after the repair. Got all the boards plugged back in. Everything's reassembled. T-con boards connected back to the panel. You got to remember those tabs, they flip up to release the cable, and you pull the cable out, or the ribbon, and so they fall back down again. And when you want to put the ribbon back in, you have to lift up that tab, slide the ribbon all the way in till it bottoms out, and then pull the tab down to lock it in place. Yeah, okay, so let's try this, plugging it in. We got a red light, let's turn it on. Oh, we have light. And the panel's lit. And it's showing HDMI 3. Oh, here, I can turn it around and show you. So, it's all working now. Yeah, one thing about working on LCD, LED TVs, even the compact fluorescent ones with the cold fluorescent tubes in them, they got high voltages in them. You wouldn't think, you know, high LEDs, okay, operate at low voltages. Yeah, well, that string open circuit had 200 volts on it, and that could kill you. So remember that when you're working on LEDs, TVs, they still have hazardous voltages inside. And yeah, some pretty nasty stuff going on in the switch mode power supply too, so keep your fingers out of there. If you really have to work on it, use an isolation transformer, and keep your fingers out. That's the best policy. So it's working now. Put the back on. I don't have a stand for it. That kind of annoys me, but whatever. Alright, thanks for watching, and we'll see you on the next one. Take care.